Hello everyone, welcome to the channel. In this video, let's discuss about what is meant by operators and what are the operators present in Python. So before starting the video, in my previous video, I have explained basics of Python. So if you didn't watch that video, I will give you the link for that video in the description. So let's discuss what is meant by operators. Operators in Python are nothing but there are some special symbols in Python that carry out arithmetic or logical computation. For example, you take like plus. This is an operator, right? So this is called this is an example of an operator. So it will be useful to perform some addition operation. So this is an example of operator. There are many operators in Python like arithmetic operators, assignment operators, comparison operators, logical operators, identity, membership and bitwise operators. And then the next thing you have to know is what is meant by operand. Operands are nothing but these are some values on which we want to perform these operations. For example, if you take this example 2 plus 3, so here 2 and 3 are operands and this plus symbol, this is an operator. So I hope you got an basic understand of what is operator and what is operand. So let's discuss the operators in Python one by one. First one is arithmetic operators. So arithmetic operators are used to perform some mathematical basic mathematical operations. For example, if you take plus, addition, subtraction, multiplication, division, there are some basic operations in Python. So for that it will be useful, like arithmetic operators. So let's discuss one by one. You all know these operators, these are just basic things. So but let's discuss those. So first one is addition. For addition we're gonna use this plus operator. So for example, if you want to add something, just we're gonna use this plus operator. So yeah, you can see this. And similarly, there are some other arithmetic operators like for subtraction we can use this subtraction operator, and for multiplication you can use this asterisk symbol, like if you want to multiply anything. And if you want to for a division you can use this, like if you want to divide you can use this for division. And for modulo division you have to use like this percent symbol. You have to understand one thing, what is the use of this modulo operator means. Using this modulo operator, if you divide some two numbers, we're gonna get the remainder. Instead of getting like quotient, we're gonna get remainder using this modulo operator. Let's see. So if you divide like 4 modulo divided by 2, you can see it's 0, so that's a remainder for this. So by using this modulo operator we're gonna get remainder. By using this normal division we're gonna get this quotient. And this for exponent, like we're gonna for if you want to find 2 power something, like some exponent value, you're gonna use double asterisk. So if you want to find 2 power 4, so you can use this double asterisk for exponent. And the next thing is float division. For finding float division you can use just simply this double forward slash. Like if you want to find 3, you can see normally if you divide 4 by 3, like if you divide 4 by 3, we're gonna get like this 1.33, right? So by using this float division it will just remove the values after this point and it's just gonna give those give the remaining value. So that's the use of this float division. So that's the arithmetic operators. And the next thing is assignment operators. In my last video we have discussed that if you want to create a variable, just we're going to use the equal to sign to assign variables. Similarly, if you want to assign something, we're going to use equal to symbol. So if you want to create a variable a, I'm just creating a variable a, I'm assigning 2 to that. So if I just print, yeah, you can see that it's assigned a to the 2 to that particular variable a. And if you want to increment, like if you want to increment this a value and again assign to that particular a, generally what we want to do is a is equal to a plus 2. That's we gonna do. Now if I print a, you can see now that a is incremented to 2. Now we can, that's the answer 4 we got. But instead of doing that in Python, we can just simply we can do like a plus equal to 2. Now if I just print a, yeah, you can see instead of using that a is equal to a plus 2, I have used this method to like assign the value in order to increment the value. So that's, you can see the a is incremented by 2. So even in this way you can just increment the value. Here you have to understand this. First what it will do means, it just increment the present value of a and just assign that value again to that variable a. So that's what this assignment operator do. So that's about this. Similar way you can do subtraction, multiplication, division, floor division, etc. Many operators are there. Similarly, we have discussed in arithmetic operations. So similarly, you can use those all things in these assignment operators. So let's discuss two more things. Like if you want to, I'm gonna define some other variable b is equal to 3. If I want to subtract 1, like if I want to subtract 1 from this 3, and again I have to assign this that final value again to b, I can just use like b minus equal to 1. Now if I just print, like if I just see b, you can see that it's decremented by 1. It's decremented the actual value of b by 1. So that's about this assignment operators. And the next thing is in Python, next operators is comparison operators. In assignment operators, for assigning we gonna use this equal to sign, right? But in comparison operators we gonna use double equal to sign. Like if you want to check compare, like whether the two values are equal, whether the two values are not equal, whether something is greater than or not. And there are some operators in comparison operators. So let's discuss all those things. First one is equal to. Like if you want to check whether two numbers, like two values are equal or not, we're gonna use this double equal to sign in order to check whether these two are equal or not. So I have already created a, let's create some two variables, b is equal to a is equal to 2, b is equal to 4. Now I will check like whether a is equal to b. Yeah, you can see we're gonna get false or true. We're gonna get these boolean values. If both the values are equal, we're gonna get true. Otherwise it's gonna return false. So that's about this comparison operators. And there are a lot of other comparison operators. We can see few more. Like instead of doing that equal to sign, we can just check whether these two are not equal, or in order to use not equal sign, we can just use this exclamatory mark to check whether these two are equal. Yeah, you can see a not equal to b. So yeah, that's true, right? A is equal to 2, b is equal to 4. That a is not equal to b. Obviously it returns true. So that, and similarly you can check whether some particular value is greater or not. Like I will check like a is greater than b. So you can see that obviously it returns false. Like a is equal to 2 and b is equal to 4, a is less than b, so it returns false. And you can check like a is less than b. Yeah, you can see it's true. And there is another operator like greater than or equal to and less than or equal to. So I will check like a is equal to, I will create another variable, a is equal to 2 and b is equal to 2. Now I will check a is greater than or equal to b. Definitely it returns true, right? That is, it returns true whether if the a is greater than 2 or a is equal to 2. In the both conditions it returns true. That's about this greater than or equal to. Similar way, less than or equal to. So that's about this Python comparison operators. And the next thing is logical operators. So in Python there are three logical operators: and, or, not. So let's discuss one by one. First, what's the use of this logical operators means? Logical operators are used to like combine some conditional statements. For example, let's take the previous example itself. A is less than 3 and b is greater than 2. I have given this. You can see it returns false. Why? Because a is less than 3 means a is equal to 2, so obviously it's less than 3, and this AND operation will return true only if both the conditions are true. That means here a should be less than 3 and b should be greater than 2. If those both conditions are true, then only it's gonna return true. Here the b greater than 2, that condition is not true, so that's the reason why it returns false. So similarly you can use OR operator. So for the same equation, so for the same condition, let's use this OR operator, a less than 3 or b greater than 2. For this OR operator will be useful, like it returns true, at least one should be true in those two. So in that condition it returns true. So that's about this OR operator. And NOT operator. So NOT operator will be useful for like reverse the result. For example, if I just use here, if I use this a less than 3 or b greater than 2, we got true. Similar is in this example itself, if we just use this NOT operator, yeah, it's written false. So opposite of true is false, right? So that's the use of this NOT operator. So that's about this logical operators. And the next thing is identity operators. Identity operators will be useful to compare the objects. It means that before in comparison operators we have used equal to to compare whether these two values are equal or not, but that's little bit different when compared to that comparison operators. Identity operators is little bit different. It returns true if both the value have same memory location. So let's understand this with example. So I'm going to create two variables, like I'm going to assign some values like x and y, and similar way I'm going to create a b, and even here I'm going to use like x and y. Now if I just use assign like this, a is b, so it means that the both values are same, like in both the variables both present, like it's both are list, both contains same values x and y. But this identity operators, I have said you before, right? Identity operators will check the object whether they both are belongs to same memory location or not. So if I just if I just assign this value to a, it stores in some particular location. If I assign this value to b, and it same again, this value will be stored in some other location. No, they both are not stored in same location, right? So that's the reason why it returns false. If I just if I will create another variable x is equal to a, I'm just assigning this a variable, I'm just assigning that to x, right? Now I will check whether a is x. You can see now it's true. It means that this particular value is stored at particular like some other location, right? So I have just here x is equal to a means along with this value I have assigned location also, location of the particular object. So that's the reason why it returning true. So I hope you understand this identity operators. And similar way you can check that there's other assignment operators like is not. So a is not, like a is not, we have to use space in between them. A is not b, it returns true since they are not belongs to same object. And the next thing is membership operators. Membership operators are used to test if a sequence is present in an object. Like for example, let's take an example like same previous example. I'm just using this a variable here, and I'm checking whether this x is present in a or not. So I'm just using x in a. So yeah, you can see it's written true. So since this x is present in A, it returns true. And similar way you can use not in. So the in and not in, those are the two membership operators. So I'm gonna check like some particular some other like L in A. So it returns false. There is no character like L in, there is no string L in this list. So it returns false. So similarly you can check not in operator even. So here you can use like L not in A. Yeah, you can see since it is not in A, it returns true. So that's about this membership operators. And then last thing is bitwise operators. And the last thing is bitwise operators. So let's in bitwise operators, what's the use of this bitwise operators means bitwise operators are used to compare the numbers bit by bit. It's gonna perform operations on each bit. Like let's discuss with some examples, then you can understand. There are in bitwise operators there are several operators like and, or, XOR, not, left shift, right shift operators. So let's discuss one by one with example. First one is and. Let's discuss this and operator. So this and operator generally in order to perform bitwise operations, we don't use this we don't use this and. We have written this and in logical operators, right? We are not going to use this here for bitwise operators. For bitwise and operation, we're going to use this ampersand operator. So let's understand how this and operation will be performed. So and operation means we generally know truth table, right? Truth table for and operation. Like so, the and operation returns 1 only if both the inputs are 1. Otherwise, in other conditions, it returns 0. So let's understand with example. So I'm gonna perform like just take a simple examples to understand. 3 and 4. It returns 0, right? How it returns 0? Let's understand with example. So I'm going to explain it in Paint. So let's take what are the values I have taken. 3 and 4, right? So I have said you right, bitwise operators it's gonna perform bit by bit. So let's convert this 3 and 4 to binary first. So 3 will be written in binary as this is the binary format of 3, and similarly if we take 4 we can represent in like this is the way we're gonna represent 4 in binary, right? So I have said you right, and operations means it's gonna returns 1 only if both the inputs are 1, right? So from this you can check. First thing is, so here from start, if we start from here 0 0, you can see 0 0, so both the inputs are 0, so it returns 0, and here you can see 0 0, it returns 0, and similar way there you can see in any there is in any way you can't find both the inputs are 1, so the output will be 0, right? So that's the reason why we got here as 0, right? 3 and 4 we got 0, right? So that's the reason we got 0. I hope you understand how this AND operation performs. And similar way we're gonna perform OR operations. OR means we're gonna use this pipe symbol just present in your keyboard on top of this enter symbol, right? It's just present on top of that. You can just use this OR symbol. In similar way, or if I just use 3 or 4, it just returns 7, right? A similar way, this OR operation is just for this OR operation, the truth table is, so this is the truth table for OR operation. It means in order to get output 1, at least one input should be 1, so then the output will be 1. That's a OR operation. So you can just use this same 3 and 4, and you can just do OR operation. That's about this OR operator. And similarly XOR operator. For XOR operator we're gonna use this cap like symbol. Well, we're gonna use this for XOR operator. This XOR operator, like for the truth table for XOR operator is, so this is a truth table for XOR operator. The XOR operator returns 0 if both the inputs are same. In the other case, like in other case it returns 1. You can see here, like when the both inputs are 0, it returns 0. When the both inputs are 1, it returns 0. So that's about XOR operator. Similarly, you can try this with the same example I have explained you in previous case. So that's about this XOR operator. And the next thing is NOT operator. Similar way we have discussed in logical operators, right? In logical operators we have discussed NOT. It means that it's gonna reverse the if it is true it returns false, if it is false it returns true. So that's for logical. In the same way here for bitwise operators, if it is 1 it returns to 0, if it is 0 it returns to 1. So that's this NOT operator. So let's discuss this NOT operator with an example. So for NOT operation we're gonna use this negation symbol, right? Negation symbol. If I just use this 9, you get -10 as output. Let's understand how we got -10 as output. So let's discuss with an example. We have taken 9, right? 9 right? So what's the binary value? How we gonna represent 9 means? So this is the binary format of 9. So I have said you, right, NOT operator, it's just if it is 0 is present, it converts it to 1. If it is 1, it's converted to 0. So in that way what we have to get is like 1 0 complement is 1, and 0 similar way here, and for 1 complement it's 0, and this is the NOT operation of this 9, right? How this value is equal to, we got it -10, right? Let's understand how we got how this value will be equal to -10. So we have to understand one thing. In Python the negative values will be stored in 2's complement form, right? So let's understand, let's decode this -10. So this 10 will be written as, so this is the binary format of 10. So if I just use this is normal 10, right? So what we got is answer is -10. So in Python I have said you, right, in Python the negative values will be stored in 2's complement form. Let's understand what's the 2's complement of this 10. So in order to perform 2's complement, first we have to find 1's complement, and we have to add 1 to that 1's complement. So first we will find this 1's complement of this. So 1's complement means just NOT operation, means 0 means 1, if it is 1 we are gonna write it as 0, 1 0 1 0 and 1. This is the 1's complement, right? This is 1's complement. This is 1's complement. And I've said you, right, we have to find 2's complement. So in order to write 2's complement, we have to add 1 to that 1's complement. So I'm adding 1 to that 1's complement, then I'm adding 1 to that 1's complement. Let's see what we will get the output here. This is normal binary addition, right? I hope you all know this binary addition. This 1 plus 1 is 0, and we get 1 as carry. We're gonna get 1 as carry, and 1 plus 0 is 1, and similarly all these are same. I'm gonna write everything 1. This is the 2's complement of 9. So if you just see this output and this output here, you can see this both are same. So that's That's how the not operation performs. So I hope you got an idea like how the computer will use this negation, how it will be useful to convert this. So that's about this. And the last two bitwise operators are right shift and left shift. So let's discuss this. So this will be useful, like let's discuss with an example. So for a right shift, we're gonna use this right arrow, double right arrow, and if you just use this, you can just see we got 0. And similar way we can just use some other same example, 1. You can see we got output as 4. So let's discuss with example. Let's discuss with same example how we got these values. So we have taken in the first example, like right shift, we have used 2 and 3, right? 2 and 3. So the binary value of 2 is 0 0 0 0 and 0 0 1 0. This is the binary value of 2. And we have given 2 right shift by 3, right? So what it will do means, first it will convert this 2 to this binary format, zeros and ones, and next thing is it gonna shift this binary value 3 times, like 3 values it gonna shift right. It means here it's 0, right? It gonna shift 3 bits rightward. If it shift right 3 bits, this 0, here it's 0, and here it's 1, and here it's 0. This all the 3 values will be moved to, like it will be moved rightwards. Then what will be present here? Here we gonna get like this 0 here and this 0 here, this 0 here. It means right shift by 1 bit means entire bits we gonna shift by 1 unit, one side right, 1 unit right side we gonna move every bit. So if I just move all the 3 bits, here it's 2 right shift 3, right? So we're gonna shift this 2 value 3 times, 3 bits right we're gonna shift. So what we will get, like 0 0, and if I move this 3, even here we're gonna get 0 0 0 0. So that's the reason why we got 0 here, right? I hope you understand right shift. Similarly left shift. So this left shift, what's the example I have taken? 2 left shift by 1. So 2 left shift by 1, right? So let's take that 2 left shift by 1. It means same 2, right? If I just shift this entire bits by 1 unit left, it means first left shift means first take this bit, we're gonna move towards we're gonna move one step left, and similarly this 0 we're gonna move left. So similar way we're gonna move right. So what we will get the output 0 0 0 0, and here we will get 0 1 0 0. It means this is the binary value of 4. So that's the reason why we got 4 here as an output. So that's about this video. I hope you got an overall idea of like how these operate, what are the operators in Python, and how to use these operators. So that's about this video. If you understand the video, like the video and subscribe to the channel. Thanks for watching.